Hi, this is a Week 4 supplement for Straight Line's Executive Black Belt course. In Week 4, we're going to start on slide 56, and this one's going to cover lean solutions.
I want to talk through, again, I think that in reading the material and in looking at a number of the tools, I don't think this will present you with any problems. And like I said, most of you have already had some lean. For the folks who haven't had a lot of lean, let's talk about it in our one-on-ones and where you might apply it. But what I want to do is I want to just talk through, here are some solutions. One thing that in fact, Tom Pisdek, and I'll write his name down so you get it. Yeah, I wrote it in invisible ink. That's not very helpful. Thomas Pisdek. Now, admittedly, he is a Six Sigma guy. He came from Six Sigma and quality, not from lean. Okay, but what he noted was that the way that he viewed lean was lean, in many ways, is a canned set of things that you use to act solutions on. Now, I don't totally buy into that, but I think he sort of has a point. A lot of the things that we think of as concepts in lean are actually solutions or almost solutions that we can apply in different places. So I want to talk through some of those solutions. And we'll talk about five of the types. One is Onepiece Flow. One is something called Cellular Flow. One is called Load Balancing. One is called Quick Changeover, or some people call this SMED. It's got the really manufacturing name of SMED. Single Minute Exchange of Die is what that stands for. I like Quick Changeover because most people get what that means, or quick. Well, we'll talk about what it means. And then the last one is pull systems, or Conbond. Talk about Conbond, and this is probably the hardest to get without doing it, so we'll spend maybe a little bit more time on that, talking about some examples. And at this point, I'm really going to do my best to try and ping you guys to see where you've applied this. Okay, so let's first of all talk about Onepiece Flow. Before we do, what we're really trying to do, if we think about it from the very, very high level, is we're trying to eliminate wastes in process. And in many cases, that means increasing the speed of a process in terms of delivery to customers and removing those delays. Okay? So I've pictorially represented this by big process steps and long, meaning it takes a long time, but also we'll notice that, for example, step 3 takes a lot longer than step 4, and there's some imbalance here, right? So we're going to be using these techniques, load balancing, Onepiece Flow, quick changeover, pull or Conbond, and cellular flow, to shrink that process and to regulate it to get it to run more smoothly. That's the name of the game here. All right. Before I do, I want to go into the concept of, and I'll write it down. Just to, you can Google it or Wikipedia it later or whatever you want. But we're going to use concepts of what's called muda. I'm going to write down all of them. Muda sounds almost the same, and Muri. Okay, now what what the heck is that? Well, muda is, if you hear this term, I think the literal translation means trivia. In other words, this is waste, the way that we usually think of it, stuff that we don't need to do that we're doing. Change this back to red. I like the word trivia. I think that works. Trivia or trivial. Okay. Mura means unevenness, and I'm struggling to spell this. Unevenness. And we can think of this as largely as variation of performance. Okay, so sometimes things perform, you get a lot of performance out of something, sometimes you get a little. So that's kind of related to our concept of variation. And finally, the last one, which literal translation is overburden, which again kind of means understanding what we can and can't do and standardizing. And there is, even and most people, most lean organizations, they focus on Muda. And in fact, when you ask people, they often talk about Muda, but they don't talk about these others. There's a lot of waste and unevenness and variation. And if you only consider this, you'll never get to this. That's one of the reasons why we look at the 7 wastes. There's also a bit of an order to this. You don't want to start with Muri, generally speaking, because if you start with standardizing some things, you can often get into trouble. So there's a bit of a order here. You probably want to look at Muda first, and then Mura, and then Muri. But think about it this way: why wouldn't you start with standardizing? By the way, a lot of companies do that. They look at a process and they say, what we really need is standardizing. Standardizing, not the first thing you want to do. You want to lean it out by taking out the Muda and the Mura first. Why? Well, let me give you an example, and it'll probably work for you. Consider a process where you've got consider any sort of process that you can automate. If you don't eliminate the waste that you're already doing, or the variation that you've got in there, let's say you automate it by putting in an IT solution. Think about how wasteful that is, or first of all, think about how expensive that IT solution would be. We've got to take care of all the exceptions. We've got to take care of all the possible errors and so forth. The second thing is, what we end up doing is suppose that we had many, many steps, and we could eliminate some of those steps because they were non-value added. Wouldn't it be better to eliminate those first rather than to institutionalize them in the code? So hopefully I've given you a good impetus for why this comes last. And by the way, it's also the 4th and 5th S, and there's a good reason for that too. You don't standardize first, you standardize near the end of an improvement. Okay, anyway, that's just kind of philosophical. Okay, so let's talk about Onepiece Flow. I think perhaps the best way to think about this is, I'm going to jump ahead just a little bit, and then we'll come back to this. Right, so I'm just going to jump to this. There's 2 examples that I hold out as sort of paragons of this. And by the way, these are just potential solutions. We don't want to be a one-size-fits-all maniac. Onepiece Flow is not always the solution, and you don't always have to get to a piece flow of a batch size of 1. Okay, but 2 companies that use this heavily and were very successful. One was Dell. So Dell Computers became extremely successful company in Austin, Texas. I guess in Red Rock, north of Austin. Very successful company, largely by letting the customer pull. If you remember, Dell in its early days was an internet-based company or a call center where you called and you basically told them the computer that you wanted. The beauty of Dell was that at that time they held no inventories of finished goods. They actually got your payment before they paid their suppliers to ship the stuff and to put it together. So that was their whole methodology, was to let the customer pull, and they were going to build you a batch size of 1, your computer. They're not going to mass produce these things and push them into retail. Now you can see that Dell has had to, in bad times, they've had to readjust their business model. So Onepiece Flow wasn't the winner-takes-all solution for them. Now you can go to Staples and buy a Dell computer. They make them beforehand, so they have to have some finished goods. So I don't want to give this as the only solution, but it can be very, very helpful. Think about the advantages in inventory. Second thing is, think about McDonald's versus Subway. I have to be careful here. I used to work at McDonald's, and in the old days, I don't know if they still do it in the days of microwaving all your food. Haven't been to a McDonald's in ages. But in the old days, when lunch would come, we had the mentality of, if we build it, they will come. So we'd put in huge batches of hamburgers, Big Macs, chicken sandwiches, fish, all that stuff. We put them in the bins so that when people came in and ordered a fish sandwich, we could just pull it from the bin. Well, what happens is, if people don't buy fish or they don't buy Big Macs, after the lunch rush is over, guess what happens to all that inventory? Well, in theory, you're supposed to throw it all out. We always did. I always threw it out, but truth be told, I've seen some people change timing numbers and keep it in there, but whatever. The point is it becomes waste or a customer hazard in any event. But Subway doesn't do that. Subway, when you come in, you order, if you want to order a veggie delight, they only ask you the questions on what they need. They only pull the bread that you want, so they don't have to make a new batch of bread as often. They don't have to throw out bread. So there's lots of advantages. But there's also an advantage in time. And the key thing is, One-Piece Flow only works if you can do it well. If you're not making a lot of errors and you're executing it fairly quickly, One-Piece Flow works. If you can't do that, it doesn't work very well. Here's an example pictorially of why it can be, of how it can be wasteful. Imagine the top process is one that uses batches. In this case, it looks like it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a batch of 10. So imagine this, that you've got a 3-step process. You put 10 things into step 1. When they're completed, you move them to step 2. When they're completed, you move to step 3. All right? What happens is, as you're completing, that first one that's complete has to wait for all the other ones to complete before you move it to step 2, and so forth. All right, if we look at that, if each one of these steps takes a minute, the total lead time to get any one of these, or the whole batch through, the whole batch of 10 through steps 1, 2, and 3, is 30 minutes underneath that one, underneath that batching process. And it's 21 minutes for the first one, whatever this first unit is. Let's say it's this one, which goes in, and it's the first one here, and it's the first one that gets out. That takes 21 minutes. All right, 10 minutes here, 10 minutes here, 1 minute here, and it's done. Now, if we're not doing that, if we're putting one in, and then as soon as that's done, we're moving it into step 2. As soon as that's done, we're moving into step 3. Here's the advantage that you can do here. You can actually move the lead time from 30 minutes to 12 minutes for the entire order, and 3 minutes for the first piece. So the first piece goes bam, 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 and comes over here in 3 minutes, as opposed to waiting for all these others. So that's the advantage. This is all the good side to One-Piece Flow. As I said, there can be some, it's not a one-size-fits-all solution, so many processes don't lend themselves to One-Piece Flow very easily, nor do they lead to a production line type of development. Okay, I'm going to move on to Cellular Flow. So Cellular Flow is a different sort of concept, but it goes with One-Piece Flow very well. And that's why I started with One-Piece Flow. Cellular Flow allows for designing something that tries to minimize. One of the things that One-Piece Flow can do is it can deal with speed and inventory. So delays and inventory, right? Those are the wastes that are really big on this one. Delays and inventory. All right. For this one, this can help us a lot with defects, I'll show you how, and transportation. And some others in motion as well, but those are the first ones that really come to mind. But it also works well with a one-piece flow mentality too. All right, so imagine this. What Cellular Flow is essentially having a team in an area such that where something comes in is also very similar to where it comes out, and as it goes around, it's done with physically close in physically close stations. UTC used this heavily in their jet engines, and they were able to get the amount of travel of their jet engines in their factories at Pratt & Whitney in Hartford down from like 5 miles of travel on the plant down to like 1.5 miles of travel on the whole thing. And they may have even beat that by quite a bit, but those were the numbers that I had 5 years ago. So a tremendous increase or decrease in the amount of transportation that was done. But there are other advantages as well. This happens to be what's called a U-shaped cell. A U, you end up at the same place that you started. And there are different types. There's a Z-shaped cell as well, but we'll deal with the U-shaped cell. Let's imagine your kitchen, and the kitchen is a station that your kitchen is very likely to be designed in this way. You might have a garage, and your kitchen may be off the garage or close to it, and you'll bring in the food, and what's close to the food? Well, the refrigerator, right? And when you want to cook something, you've also got some stuff that you're going to pull from the shelves and the refrigerator. You pull it right there. You can work on it on the counter, and then you have some counter scraps which you put into the sink. Move those right into the stove or the oven, and then we can put it on the service area and can go right to the living room or dining room or wherever it goes. And oh, by the way, the garbage that's created can go right back out of the kitchen as well. So it sort of minimizes all that travel. So that's one of the things. Another advantage that you get is that because if this is not just you working on this, so if you can imagine it's a restaurant, well, you've got the people who are working on different areas communicating with each other. So you can actually keep from passing on errors instead of you do what's called controlling errors at the source. So if this is a different person, let's say this is person 1, and this is person 2, I'll just say P2, that if this person gives the P2 a bad carrot, and they're supposed to be, say preparing the carrots, they'll let that person know right away. And so we can start to get bad carrots out of the refrigerator right away. We don't have to wait till it's passed on to a customer for somebody to say, oh my God, I got a rotten carrot. Or worse yet, that's the worst case. But also bad would be, hey, we made the dish and it's got rotten carrots in it, and we noticed it and we don't serve it, but it's still a problem because we throw it out now, and now it's waste. Okay, so Cellular Flow can help you with both of those ideas. All right, I want to stop and I want to ask before I go on. I want to ask the folks who are on the phone. I see most people are muted, but if you could take 15 seconds to write down where you have applied either Onepiece Flow or Cellular Flow, and maybe take a minute to share that experience. So I'll give you 30 seconds to write it down. Okay. Is there anybody on the phone who could share where they've applied either Onepiece Flow or Cellular Flow before? Okay. No answers. That's okay. If we can, that's okay if you haven't yet done it. But as you're going through and applying these things, I believe that you'll find that there's many, many places where this can be applied, and we'll work on that in a little bit. Okay.
Yeah, Mark, one thing that we look at in healthcare is since so much of what we do is patient-centric,
yep,
a lot of our larger processes are naturally Onepiece Flow.
Okay, excellent, right.
Now,
yeah, and I should
processes like labs and things like that, well then, yeah, you'll encounter some batching, but we're kind of an anomaly like that.
Yeah. Well, the interesting thing is, I think, and I did a lot of work with Cigna, and so this will probably apply at CCI as well, that there were a lot of things that were naturally Onepiece Flow there as well. But that's an excellent point. Is that in this case, if you're really dealing with one patient at a time and it's a significantly different path, then it kind of forces you into Onepiece Flow. You can't batch up patients, at least not that easily. Good point. But I can imagine things like paperwork, billing, mixing drugs or medication, interfacing with the pharmacy, that those could easily be batched up. And a lot of time batching processes are things that come about because we're trying to minimize the wrong thing. What I mean by that is, and hopefully this discussion some of this is helpful, if we do have a siloed mentality and we're thinking in terms of this rather than this, well, if I'm going back and forth from the pharmacy and that's my process, what do I try and minimize? I try and minimize my time, not the customer time or not the end-to-end time of the transaction. And so I might batch up. I might make it more efficient for me or for my time rather than for the overall. That can happen quite a bit. All right.
That's a good point. One thing we teach our lean practitioners is that batching is a flag. So you can't just go in and say, do things one at a time. You have to figure out why they're batching and dig down.
Right. And that was kind of like, that was kind of what I was getting. I'm glad that you pointed that out. And I think that's maybe that's another good way of looking at it. That was kind of why I was saying that don't think that these are just solutions that are always going to work. You have to understand sort of why it's done. When I learned a lot of stuff, I learned like with mail, through mail order, batching in terms of economic order quantity. And the idea was, well, you want to do some batching in your mailing because otherwise if you're doing one piece at a time, you're going to spend a lot more money. And while that's true, you find that, man, the delays, and it causes so many delays that sometimes it is better to incur the cost of the extra cost of the shipping or whatever. And it's worth asking is the point. And I think that's what you're talking about. It's time to drill. I like that. It's a flag to look for more. Okay, there are a couple more that I wanted to cover. One is load balancing. I'm sure that many of you basically get it already, but this is a very strong and commonly used lean solution. Imagine a process that has that works at very irregular pace or is overstaffed in some place and understaffed in another. We often have suggestions of solutions like cross-training or switching around people for capacity. Those are good ideas sometimes. And so how can you tell? Well, if you're going to be doing load balancing, we'll start with takt time, which is really sort of how much, what's the demand rate for this product or service. It just means like how many minutes or how many hours do we usually have in order to complete this. And then we'll break that up into what the steps usually take. This is actually a tool that I've given as a template, so you should feel free to use it. And it's called load balancing. Here it is, and basically, I'm not going to. I'll show you how this works, but basically, you take your overall demand rate. This would be, if this is in seconds, for example, this would mean that every 90 seconds, on average, we need to produce something. That may be a customer call. It may be something else. So let's look at the average time it takes us to produce something in step 1. Let's suppose that this had 5 steps. In step 2, in step 3, in step 4, in step 5. So the first thing is it gives you a picture of how long things are taking in each step. So it can tell you, okay, yeah, if we're going to regulate this, we may want to put more capacity on step 3, or we may want to cross-train people in step 4 and step 3, such that when the people who are working in step 4 are done with their job, they can move over. So you can imagine this conceptually as you go into McDonald's and the drive-through gets backed up, so they take somebody from the inside counter who has been cross-trained on drive-through, and they put them on the drive-through. Okay? You can imagine that. Now, in this particular tool, it also looks at what's called the balance sum And if the balance sum is is greater than the process steps, it means that you cannot fix the problem only by load balancing. If you think about it, the perfect solution, perfect balance would be if each one of these took 90 seconds to do, and we were doing one-piece flow, then in theory we could complete one thing when we were starting another, and it would work out that way. So this just kind of gives you a tool to say whether you can solve the whole problem or part of the problem by load balancing. The picture shows you how unbalanced it is, and this kind of gives you an idea in the perfect scenario if you're meeting all of the if you would be able to meet the customer needs. So that's what that is. All right. So that's load balancing. And again, I'm sure that most of you are familiar with some people call it job sharing, and so forth. All right. Let's talk about two more. One is quick changeover. I know that one of you is using this a lot. But here, this is one that is very, very common in terms of being very effective. As I said, it's sometimes called SMED, or single minute exchange of die. In manufacturing, what this means is we don't want to move from doing one task to another by taking a lot of times in delays. So it may be we're going to start a new production batch, like if we're running one type of prosthetic limb and then we're using a different type of prosthetic limb, manufacturing it. We don't want to have to take a long time tooling that up. Or if it's we're moving between, say, shifts at a behavioral health call center where you're taking people who are on a suicide hotline. You don't want to leave people hanging on the line too much because we're changing nurses or something like that, or psychiatrists who are talking on the phone. So anyway, some examples of fixing this would be like hydraulic lifts and readily available tools. There's a company called Synthes that did an amazing job of that, where they had tools on a hydraulic lift that went below the plant floor. And when they needed to retool, they just would bring up the new tools right from underneath, and they'd be ready to go in seconds. To other things where like staggered shifts can be helpful. Instead of leaving people hanging, maybe you have a 15-minute overlap of shifts for people to get prepared to go on, and so forth. In non-manufacturing, you can think about things like pre-screening questions so that people come on, they're ready to go. The person who shows up, if they have an appointment, if the appointment really starts at 10 o'clock, they're there at 9:45 filling out their history or whatever. Or there are standard templates or scripts. One thing I can tell you that I dislike at a lot of medical practices is they make the appointment at 10. They say, oh, can you be here at 10? And then when they pre-call you and say, don't forget to come for your appointment at 10, and oh, by the way, can you come 15 minutes early? That one doesn't work for me. Why don't you have me come at 10 and really start the thing? If you need me to do some pre-screening questions, plan for me to do the 5 minutes of pre-screening questions at 10, or tell me to come in at 9:45 at the original appointment. All right. What can often happen in many offices is lack of ownership and lack of standards is really causing delays in the changeovers. So confusion over who owns what often is a major problem in quick changeover. However, having said this, and like I said, at least one of you I know is actively doing this, and so I know that you really buy into this. Here are some things. This can yield very, very big dividends if you do this, and if you take this mentality of it's the delays between the process steps that you can really beat down and really make a big difference in. If you do it, it's really absolutely vital to involve the people who perform the work and to really understand what they need to do each task and what they need to prepare each task to get it ready. Keep a clear scope of what's really being improved. Otherwise, you don't get the buy. You're asking people to do a lot of things that they may or may not believe really will make a difference. And check. When you enact a solution, make sure it actually works. Don't just do it out of logic. Make sure, do it and then test to make sure it actually works to help eliminate those delays. Quick changeover can really be an excellent idea. I have in here videotaping is also very helpful. Sometimes we don't really see what we delay on. So it's a simple and strong idea. I understand there are many different legal obstacles to that sometimes, but if you can do it, it can be very, very helpful. All right. I do want to talk very, very, very briefly about Conbond, at this point I'll just talk about what it is, and then maybe we can have I'll have you read it, and you can maybe see it in action. When I first learned Conbond, basically what it is it's a process, it's a system that helps you visually regulate things. You can regulate inventory, you can regulate how often things are done, and so forth. All right? So that's all it really is. When I did it, it was a cart. In many cases, it's a pull system with cards, and I believe the Japanese word literally means card. But think about it this way. I believe it started in the mini marts where people visually stacked their inventory such that when it was out, they knew it was time to reorder. So examples for this can be literally visual cues like signs at the bottom of, say, a printer paper that says time to reorder, things like that. All right. Without going into it too much, I see that we're hitting the top of the hour. I do want to take a little bit of time to recalibrate and talk about what we're going to cover on Thursday, and to remind you about the assignments that are due and things. There is an exercise that's going to happen in the next assignment that you'll need to work through, and so forth. Okay. But I believe that none of this, except maybe Conbond, will present you with any problems. What I have on my list is to provide you with a